thought of going back in over 45 years. And the fact that NASA has repeatedly admitted that we can't go past low Earth orbit.
This next generation spacecraft will enable America to explore beyond low Earth orbit.
We must solve these challenges before we send people through this region of space.
Right now, we only can fly in Earth orbit. That's the farthest that we can go.
The kinds of technologies that we're testing out on Space Station are definitely helping us with our goals of going beyond low Earth orbit.
Early in the next decade, a set of crewed flights will test and prove the systems required for exploration beyond low Earth orbit.
Isn't the slightest bit worth worrying about. And by
the plan that NASA has is to build a rocket called SLS, which is a heavy lift rocket. It's something that is much bigger than what we have today, and it will be able to launch the Orion capsule with humans on board, as well as landers or other components to destinations beyond Earth orbit. Right now, we only can fly in Earth orbit. That's the farthest that we can go. And this new system that we're building is going to allow us to go beyond and hopefully take humans into the solar system to explore. So the moon, Mars, asteroids, there's a lot of destinations that we could go to.
I'm going to start that over again just to make sure I saw what I thought I saw. Did you start the ISS show with a green screen? Yep, they did. I'm sure they'd never use it to fool us. How dare you insinuate men could ever lie? I'm appalled. Alrighty, we're going to get to the bottom of this. Can you see stars from space? First up, Don. Well, then you got Alik Pettit and Mike Massissimo. Watch these two and you decide. Are these two men honest? After that, we're going to hear some others, and we will get our definitive answer. Here goes.
Whilst
From
Mark
space,
Cameron. This is from Mark Cameron.
Whilst in space, have you ever looked away from Earth into the black void?
Yeah.
All
because
the
you can
time.
see.
Yeah,
Because you can see the stars.
Oh yeah.
You know, and pretty much all the time you can see the stars.
Yeah. It's not
which
a
is
black
cool
void.
thing.
I mean, it's black, but there's all kinds of little polka dots.
There's all the stars there, and the cool thing is about it, you can see it during the day.
Yeah, you can, and there's more than stars. You can see planets. You can see moons.
You see the gas Magellan clouds of the
you
Milky Way
see
galaxy.
the Magellanic clouds.
Magellanic. See, I just wanted the Magellan
there's a large
clouds.
one
I didn't
and a
want
small one, right?
Yeah.
And then you can see the zodiacal lights.
Whoa.
Those are amazing. Right before
the lights
sunrise.
of the zodiac.
The lights of the zodiac, the zodiacal lights. Okay, you can see those.
Which are
and
what?
Then you
Explain
can see
those
the
to
upper.
us.
Oh well,
I mean, I know what they are, but explain it to the
it's
audience.
This big. It's this vertical column of fuzzy glow that comes up perpendicular to the horizon shortly before the sunrise.
Every time?
No, it depends on the viewing angle and such. Not every time, but if the viewing conditions are right, you see this big fuzzy glow that goes way up high, maybe 30 or 40 degrees above the horizon, perpendicular to the horizon, and it's this fuzzy glow. It's a zodiacal light.
But one thing to add to this, I think, which is kind of interesting about being able to look into the black void, is that we can't do that when the sun is out here on Earth. And it's not because the sun is so bright. It's because this atmosphere. Right? The light comes through the atmosphere and refracts, and we see blue. It's scattered. We see blue.
Scatters.
So what we see is we see the blue color because the way the light gets bent. Was it only the low?
Scattered.
Scattered, but it's the wavelength of the light that penetrates.
Yeah, it's 1 over lambda to the 4.
Right, and that's the blue light.
Really
so blue light is what? The low wavelength or the high wavelength?
Low wavelength.
Okay, so only the low wave.
Yeah, the short wavelengths get scattered.
And that's why we see blue.
More than the long wavelengths.
Right.
Here's another one.
All right, we'll be keeping track so that we can get a definitive answer here. So far, we've got Mike and Don both say yes, you can see the pinpoints of starlight from space. Who's next?
And when you're in space and you're looking into deep space and you're on the sun side of the orbit, the sunlight washes out all the starlight, so you can't see any stars, just like here on Earth.
All right, that's Leroy. He's a no.
We were never able to see stars from the lunar surface or on the daylight side of the moon by eye without looking through the optics.
The sky is a deep black,
when viewed from the moon as it is when viewed from cislunar space, the space between the Earth and the moon.
The sky, of course, was black, but it had sort of a velvet sheen to it.
The biggest visual surprise was just how black the sky was. You have a brilliant sun, brighter than any sun you normally would see, even here in New Mexico. You have these extraordinarily high mountains. We were in a valley deeper than the Grand Canyon. But then you have this black sky, a sky blacker than black.
When you look out into deep space away from the sun, it's the darkest black you can imagine.
Just the inherent beauty of it, the velvet, bottomless bucket of the universe.
If you're there in the daytime of the moon, you see a full night sky of stars, even with the sun in the sky as well. You don't see stars in the daytime on Earth, not because they're not there, but because the atmosphere is aglow with scattered light from the sun. If you take away the atmosphere, the sun will still be there, but the sky goes dark. That's what the folks get when they go to the edge of the atmosphere, and they're calling that the edge of space. But when you get to the edge of the atmosphere is no longer between you and the rest of the universe, and the stars reveal themselves just as they would at night. So everyone knew this. So you see these photos.
I've often tried to explain the difference between darkness, when you turn out the lights and it's dark in here, or blackness. Blackness is the endlessness of it all. It's hard to comprehend.
Well, it certainly looks like these guys have no clue.
.com, and I've got the link there for that. It says, the Earth is protected from fast-moving killer electrons by an invisible plasma shield, which is located thousands of miles above the planet's surface, according to researchers at the Massachusetts Institute of Technology, MIT, and the University of Colorado, Boulder. High above the Earth's atmosphere, harmful electrons that make up the outer band of the Van Allen radiation belt travel at nearly the speed of light, pelting everything in their path. Exposure to such high-energy radiation can harm satellite electronics and pose serious health risks to astronauts. However, despite their intense energy, these electrons circling around the planet's equator cannot come below 7,200 miles from the Earth's surface due to the shield, scientists said in a study published in the journal Nature on Thursday. It's almost like these electrons are running into a glass wall in space, Daniel Baker of the University of Colorado Boulder and the study's lead author said in a statement. Somewhat like the shields created by force fields in Star Trek that were used to repel alien weapons, we are seeing an invisible shield blocking these electrons. It's an extremely puzzling phenomenon. The invisible shield, dubbed the plasmaspheric hiss, is made up of very low-frequency electromagnetic waves in the Earth's upper atmosphere. Scientific data and calculations have helped researchers deduce that the hiss deflects incoming electrons, causing them to smash into neutral gas atoms in the Earth's upper atmosphere and ultimately disappear. It's a very unusual, extraordinary, and pronounced phenomenon, John Foster, Associate Director of MIT's Haystack Observatory, said in a statement. What this tells us is if you parked a satellite or an orbiting space station with humans just inside this impenetrable barrier, you would expect them to have much longer lifetimes. That's a good thing to know. The latest study is based on data collected by NASA's Van Allen probes that are orbiting within the harsh environments of the Van Allen radiation belt. Oh, you mean the one that they just flew through, no problem, back in the 60s? Huh, in the 70s? During the study, the researchers observed an, quote, exceedingly sharp barrier, end quote, against harmful electrons, which was steady enough to withstand a solar wind shock in October 2013. To determine what could create and maintain such a barrier, the researchers considered a few possibilities, including effects from the Earth's magnetic field and radio signals from human transmitters on Earth. Oh yeah, it's our Walkman that's causing this, whatever. You know, and there's another article I should post where they're saying they basically want to poke a hole or blow up or eliminate even the Van Allen belts. Okay, check this out. February 27, 2014, okay, last year. Physicists plan to wipe out Earth's Van Allen belts with radio waves. Got a depiction here of the Van Allen belts, what they look like here. It was just last year that physicists thought they had found the origin of Earth's Van Allen radiation belts, and now a prominent group of them wants those belts dead. It's understandable given the frustration these areas of space can cause to modern astrophysicists. If you want to launch a satellite or a telescope, let alone a human being, the Van Allen belts will be a painful thorn in your side. So, says a growing group of astrophysicists, why not wipe them out altogether? It might seem odd to hear scientists propose destroying a feature of the natural world, but there is a decent scientific argument to be made that these belts provide us nothing useful and that we could lose them without a single negative effect. These guys, they think they came from monkeys, okay? This is the way the Earth is... Okay, all flat Earth globe arguments aside, okay, it's understandable, at least as far as we've been told, that there is a belt of radiation over us. And this belt of radiation apparently helps to protect us from other harmful things coming our way from the sun or what have you. You know, regardless of whether the Earth is a globe or flat,